Hello students. So today in this video we will study the theorem 6.2, that is the converse of the basic proportionality theorem. So in our previous video already we have studied what was the basic proportionality theorem, and already we have proved this theorem. Now in this video we will learn the converse of basic proportionality theorem, or it is also called the Thales theorem. Now first let's recap what was the basic proportionality theorem. So basic proportionality theorem states that if in a triangle, let's suppose this is the triangle ABC. In this triangle, if we draw a parallel line, so this parallel line you have to draw in such a way so that it should intersect the any two sides of the triangle. Let's suppose in this triangle, this parallel line DE parallel to BC, and this DE intersecting the AB side at point D and intersecting the AC side at point A. So if in a triangle this DE parallel to BC, then this parallel line divides the two sides in the same ratio. So if DE parallel to BC, then from the basic proportionality theorem we can say that this line divides the two sides in the same ratio, that is AD divided by DB will be equal to AE divided by EC. So this was the basic proportionality theorem. Now in this video we will study the converse. Converse means just opposite. Now according to this converse of basic proportionality theorem, if a line, okay, first let's understand with the diagram. Now according to converse of basic proportionality theorem, let's suppose it is a triangle ABC, and in this triangle a line is there. Now parallel line is not given. A line divides the two sides in the same ratio. Let's suppose this point D and this point E. Now what is given here? This AD divided by BB is equal to AE divided by EC. So according to converse of basic proportionality theorem, if a line divides the any two sides of a triangle in the same ratio, then this line must be parallel to this line. Then this DE will be parallel to BC. So this is the converse of the basic proportionality theorem. Now what was the statement of this theorem? Let's write. You can note down this statement in your notebook. So if a line, now parallel line is not given, if a line divides, any two sides of a triangle in the same ratio, if a line divides any two sides of a triangle in the same ratio, then the line must be parallel to the third side. So according to this theorem, if a line divides any two sides of a triangle in the same ratio, then the line surely will be parallel to the third side. Now the way we have proved the basic proportionality theorem, now this converse of basic proportionality theorem also we are going to prove. So first, to prove this theorem we have to draw the diagram first. So let's suppose this is the triangle ABC, and this line divides the two sides in the same ratio. So first, given, what is given? Given one triangle ABC, and in this triangle this AD divided by DB is equal to AE divided by EC. So this information is given. Now after given, to prove. So what we have to prove? We have to prove this DE parallel to BC. Now to prove this theorem, we have to construct something. Next, given to prove. Next step is construction. Now draw a line. Let's suppose A, B, C, D, E. Let's suppose this one F. Draw a line D, F. Now given to prove construction. Next, proof. Here we have to prove this DE line parallel to BC line, isn't it? But we will not consider that DE is parallel to BC. So this is called method of contradiction. So right, assuming that DE is not parallel to BC. This is the sign of not parallel. Now if this DE is not parallel to BC, we will consider this DF is parallel to BC. Now let us consider DF is parallel to BC. Now this equation you give as the equation number 1. So see, this is called method of contradiction. We have to prove this D is parallel to BC, but we have considered that DE is not parallel to BC. Now since in this triangle, ABC, in this triangle what we consider, this DF is parallel to BC. So if in a triangle, if a parallel line is given, we can apply the BPT. So by basic proportionality theorem, what we can say, this AD divided by DB is equal to AE, not AE, this AF divided by FC. This one you give as the equation number 2. Now you observe the equation 1 and 2. In both the equation, the left hand side is same. So if in this equation 1 and 2, if left hand sides are same, we can equate the right hand sides. So what we can write? From equation 1 and 2 we get. So what we'll get? AE divided by EC is equal to AF divided by FC. So see, left hand side is same, so we have equated the right hand side. Now add 1 to both the sides. Add 1 to both the sides, right? AE divided by EC plus 1 is equal to AF divided by FC plus 1. Now take the LCM. So this will be EC, this one is AE plus EC is equal to FC, this one is AF plus FC. Now this one is EC. Now AE plus EC, look at the diagram. AE plus EC, what will give? AE plus AC will give us AC. Now AF plus FC, AF plus FC. If we add the AF then FC, then also we will get AC. Now both the side AC is there, this can cancel out. So what we will get? EC is equal to FC. Now this EC and the FC, when it will be possible? This EC will be equal to FC. It is only possible if this E and the F point, they coincide with each other. So next what we can write? See, when this EC will be equal to FC, right? This is only true when the point F coincides. This is only true when the point F coincides with the point E. Now what we proved? This E and the F point, they are the coincident points. So already what we considered? This AF is parallel to BC. Now in place of F we can write the E. Why we can write? Just now we have proved this E and the F point are coincident points. So AE will be parallel to BC. So hence proved. So this is called method of contradiction. Initially we have considered this DE is not parallel to BC, but we got wrong. After considering this assumption, our supposition was wrong. So in this way we can prove the converse of the basic proportionality theorem. Thank you.